Okay, today we're going to be looking at problem number 54 on page 322. The first thing it would like to know is the probability of A winning both of their matches in this round-robin tournament, as well as B winning their match against C. So we're basically looking for the probability that A wins 2 times and that B also wins once. And that N symbol, of course, is an intersection. So once I have that notation, all I need to do for this is just multiply these together because these are independent events. I do not have to worry about any conditional probabilities. So 0.08, 0.07, and 0.7, 0.8, 0.6. Multiply those together and that will give you your correct probability. So that gives you the answer of 0.336. When I look at question B, it wants to know the probability that A wins both of those matches. So basically simplifying a little bit because I no longer care what happens to B, so I just need the probability of A winning 2 times, which would be 0.7 times 0.8, which is going to give you an answer of 0.56. Do notice that when you add multiple conditions, your probability does decrease because it's more difficult or less likely to satisfy multiple conditions than a single condition. Now the probability that A loses both of the matches. Well, now for A to lose both matches, the probability that A is going to lose the first match would be 0.3. So I have 0.3 that A will lose the first time. The probability that A will lose the second match is 0.2. So the probability that they will lose both matches is 0.06. Notice that winning twice and losing twice are not complementary events because winning 2 times is not the opposite of losing 2 times, because winning 2 times would actually be the opposite of not winning 2 times, which would include the possibility of you splitting a win and a loss. And then for part D, it wants the probability of everybody winning at least once. Okay, there are 2 different ways that can happen for part D, so I'm going to go over here and split them up. The first thing that can happen is I have to consider the probability of having A over B and B over C, but now having C win over A. So the probability of those 3 things would be the 0.7, the 0.6, and then for the last one, the 0.2. So that is one possibility. The other possibility I have to consider is the probability that A could beat C, but that C could turn around and beat B, and B could turn around and beat A. So this secondary probability, this is one possibility here. The second one would be A could beat C at 0.8, and then we have C pulling off the upset of B with 0.4, and then B beating A with a 3% chance. Now what I would need to do is get those 2 probabilities, and since it could be the first event or the second event, either of those 2 things, what I would need to do is add those 2 probabilities together. So the first set plus the second set, add those 2 together to get your correct final answer. And your final answer should be 018.